You see, when you are studying physics, you are talking about many kind of velocities, like linear velocities, instantaneous velocities, average velocity, final velocity, angular velocity. I don't know what are the different more types are there. Okay, so can you guess what type of velocity I am going to talk today? Guess it. Yes, guess it. What type of velocity I am going to talk today? Can you guess? Okay, you can't guess. So I'm going to talk about drift velocity. So today's topic is drift velocity. So what exactly the drift velocity, that we will discuss today. I divided this video in two parts. First part I am going to talk about thermal motion and thermal speed of electron, and the second part I am going to talk about drift velocity of electrons. Suppose we got a metal plate and we are heating the metal plate. Then what will happen to the metal plate? What happened to the electrons? Are the electrons are moving or not moving? When we are heating a metal plate, what happens to the electron? Answer is, when we are heating the metal plate, the free electrons. You see, whenever you are telling a metal is having what? Metal and non-metal, what is the difference? You see, metal having the free electrons, non-metal having no free electrons. There are no free electrons in non-metals. In metals, there are free electrons. When you are heating the metal, what happens? What happens? The free electrons inside the metal plate, inside the metal rod, or inside the metal wire, whatever it may be, it is made up of metal. So these electrons move zigzag motion. That means they have the random motion inside the metal plate. And these electrons move from one point to another point as shown in this graphic animation. So when we are hitting a metal rod, what happens? The electrons are moving inside the metal rod only. They cannot escape outside the metal rod. So whenever we heat a metal rod, the electron move inside the metal and have the random motion, but they cannot escape outside the metal rod. This is what the summary. So when we are heating a metal rod, electrons are not able to come out of the metal rod. What is the reason? Why electrons cannot come out of the metal rod on heating? Here, to make you understand what exactly inside the metal strip, here is a atom. This is a metal atom. And this metal atom having some electrons. To make you understand, I have shown here 4 electrons. There may be more than or there may be less than. And in the right side, 1 electron is outside the atom. So 1 electron left the atom, we can see. So left side, the all electrons are inside the atom, but in the right side, the 1 electron is outside the atom. It is no more called as an atom. It is called metal ion. This is the metal ion. So when the atom loses 1 electron, it is called metal ion, and it is lost the electron. Therefore, it is called metal positive ion. So in a metallic strip, there are the thousands of positive metal ions and thousands of free electrons. I am telling you thousands of thousands. No, it is crore of crore free electrons are available, and crore of crore positive metal ions are there in a given metal strip. Thus, inside the metal strip, there are the large number of free electrons and large number of positive ions as shown in the figure. Now, electron having negative charge. Already they have the negative charge. And due to the removal of electron, there are the positive ions inside the metal strip. So when there are the large number of free electrons, the large number of positive ion also present. So while electrons are moving, why the electrons are moving? Because we are heating the metal strip. When you are heating the metal strip, electrons acquire some energy. Free electrons acquire some energy. They keep on moving from one point to another point. But while they are moving, they are attracted by the positive ions. Therefore, what happens? The bounce. Electrons bounce on the positive ion, and as soon as they bounce, due to their energy, they rebounce and they again move away from the positive ions. But they, as soon as move away, their direction changes, but they are again attracted by the positive ions. The process keep on going. So this is the way the electrons move from one point to another point when you are heating the metal strip. So this is nothing but called the thermal motion in electrons. So we can also call it as thermal agitation. So electrons move when you supply the heat to the metal strip. But the average velocity, all electrons are not moving with same velocity. Therefore, we have to find out average velocity. So the average velocity of all electrons due to the applied heat is nothing but called average thermal velocity. So summary is, whenever you are heating a metal strip, electrons moving in the different direction and their average velocity nothing but called thermal velocity. Suppose I consider a single electron. In fact, there are the crores of electrons are there, free electrons. But to make you understand, I am just talking about single electron. Now this single electron is attracted by this positive ion, and after that there is a collision. After the collision, it direction changes and collide with another positive ion, and thus it will suffer multiple collisions, and as after the collision the direction of electron changes, but the velocity of the electron remain the same, only the direction of the electron is changing. And thus in a piece of metal, when you are heating the metal, what happens? The electron suffers multiple collisions, and every time the direction of electron is changing, but after the rebouncing the velocity of the electron is not changing, it almost remains the same. Now let us say the v1 is the speed of the velocity of first electron. Here is said, you see, whenever you consider only the direction, then we use the word velocity. If you don't consider the direction, then you consider as a speed. Okay, so don't confuse yourself with the speed and velocity. So here is the v1 is the velocity of the first electron, and v2 is the velocity of the second electron. If we add all the velocities, v1, v2, v3, v4, how many electrons are there? There are the n electrons are there. So we assume that there are the n electrons. So velocity of the first electron, velocity of second electron, third electron, fourth electron, fifth electron, and so on, the nth electron, and so on, nth electron. So Vn is the velocity of nth electron. And suppose you want to find the average of this, then what will you do? You will divide by n. So this will give you the average velocity of the electrons. Now in short and sweet form, in the summation form, this can be written as summation start from I equals to 1 to n and divided by 1 upon n. Here we generalize, so we write I. So this will give you the average velocity of the electron. Now since the electron moving in forward direction, many of the electrons are moving in the forward direction and many of the electrons moving in the backward direction. Similarly, some electrons are moving along y direction and some of the electrons moving in the negative of y direction. Similarly, some electrons are moving in the positive z direction and some of the other electrons moving in the negative of z direction. Thus, if you consider the all electrons and if you want to find their average velocities, then the average velocity of all the electrons due to the thermal motion is taken as 0. Some time ago, there was one question. What was the question? When we are heating a metal, why electrons are not coming out of the piece of metal, even though they are having the random motion? The answer is that the average velocity due to the thermal energy given to the piece of metal, the average velocity of electron is equals to 0. Since the electron not having the velocity, then how they will come out of the metal surface? How they will come out of the piece of metal? Therefore, when we are heating a piece of metal, electron have the average velocity equals to 0. Therefore, no electric current when we are heating a piece of metal. There is no electric current. There cannot be the electric current if we are heating the piece of metal. So when we heat the piece of metal, any metal, whatever it may be metal, there is no current is produced. So summary is, whenever a piece of metal is heated, there can't be electric current. So when you're heating a piece of rod or a piece of copper or a piece of aluminum or a piece of gold, there cannot be electric current. So what to do to get the electron flow from one end to another end? For that we have to apply electric field. Now let us apply the electric field to the piece of metal and see what happens. Suppose I apply the electric field on electron. This is the electron, and some electric field is applied to the electron. So what will happen? The electron is attracted by some force towards the positive terminal, because electron is negatively charged particle, so it is attracted by the positive terminal of the battery. How much force? The force is given by the formula charge multiplied by electric field intensity. Therefore, force acting on the electron due to electric field is nothing but minus E multiplied by E, and force is nothing but given by mass into acceleration. So m is the mass of electron. Therefore, my ma equals to minus E upon E. Therefore, acceleration in the electron is given by minus E upon m. This is the formula for acceleration established in the electron due to applied electric field. Now let us assume in a given piece of metal we remove all positive ions. So you see I am removing all positive ions. Now there is no question of bouncing and rebouncing of electron, because the entire piece of metal there are no positive ions, only a single electron is present, and we have applied the electric field here. So what will happen? As soon as we apply the electric field, the electron is accelerated towards the positive terminal of the battery. And what is the value of acceleration? What is the value of acceleration? The value of acceleration nothing but A equals to minus E multiplied by capital E upon m. This is the value of acceleration of electron. Now we know that acceleration nothing but change in velocity upon time. So acceleration nothing but change in velocity upon time. So this acceleration nothing but minus E upon m. Suppose I want to find the velocity of the electron, then it would be equal to minus E multiplied by E upon m multiplied by t. This would be the formula for velocity of the electron. Now consider the collision of electron in slow motion. Here we got the electron. When we apply the electric field, it is attracted by the positive terminal of the battery, but it cannot directly go to the positive terminal because of presence of positive ions. So as soon as it comes inside the metal piece, it is attracted by the positive ion, but as soon as it collides with the positive ion, it bounces and it collides with the another positive ion, again the bouncing, again the so with collide with another positive ion, it will suffer the multiple collisions with the positive ions, and this is the last collision. After this, the electron will come out of the given piece of metal. Now electron was here, so this was the first collision, and this was the second collision, this was the third collision, it was the fourth collision, and so on. This is the last collision, and after the last collision, the electron ultimately coming out of the piece of metal due to applied electric field. Let us say the time after the last collision, that is the time elapsed after the last collision and the electron coming out of the metal piece. So that is nothing but Ti. So Ti is nothing but time elapsed after its last collision. And after last collision, there are no positive ions left. It is not attracted by the positive ion. So what would be its velocity after the last collision? So let Vi dash is nothing but velocity immediately after last collision. Here I had considered only one electron, but it is a story of every electron present in the piece of metal. Therefore, I have written I here, that is a Vi, the suffix I have written because I am considering particular ith electron. I am considering particular ith electron here. Therefore, I am writing here Vi and Ti. So it is the story of every electron which is moving inside the piece of metal and coming out due to the applied electric field. Now here we apply the kinematical equation to know what was the velocity of electron after the last collision. So we have the equation V equals to U plus AT. This is the kinematical equation where V nothing but final velocity, U equals to initial velocity, A equals to acceleration, and T equals to time elapsed after last collision. Now this final velocity, let us denote by the symbol Vd. D is the suffix, and initial velocity, that was the velocity before the last collision. So that is nothing but Vi, that was the average velocity, plus what was the acceleration, that is nothing but minus E multiplied by capital E upon m, and time is nothing but Ti. Here even for the time we have to consider the average time, because here already we consider the average velocity. So for time, even for the time, we have to consider the average time. Now how to find the average time? T1 is the time for the first collision, T2 is the time for the second collision, T3 for the third collision, and so on. Tn for time for the last collision divided by n. This value nothing but called tau. This tau technically called as relaxation time. Therefore, the above equation becomes Vd equals to Vi average value plus minus E multiplied by E upon M. Now Ti, average value of the time, is replaced by tau, that is a relaxation time. Now we already know that the Vi average, the average velocity of electron is 0. Therefore, Vd equals to 0 plus minus E multiplied by E upon M into tau. Vd equals to minus E upon M multiplied by tau, where Vd nothing but called drift velocity. So this is the expression for drift velocity. From above discussion, now we can define drift velocity as follows. When a conductor connected across a potential difference, the free electron drift towards the direction of positive terminal. The small average velocity of free electrons along the direction of positive potential is called as the drift velocity. Practical importance of drift velocity. Drift velocity helps to understand how rapidly digital data can be transferred from electronic devices. Drift velocity plays a crucial role in design of power transmission lines. Drift velocity helps us to control temperature and thermal management of electronic devices. So ultimately, we came to the end and we came to define what exactly the drift velocity. I hope your concepts regarding the drift velocity have been cleared. If not cleared, please tell me why. If cleared, please give me your comments. Write something in the comment box so that I come to know how do you find my videos. Because your comments, my motivation. I want to give you more better knowledge, more and more knowledge in simplified form. But if you are not giving any comments, you are not subscribing, how I will get motivated? So your subscription and your comments are nothing but the oxygen for my videos. So that's all in this video. Meet you again with another topic. Till then, wish you good luck. All the best. Once again, like, share and subscribe the channel and share it with your friends. Bye bye. See you. Good luck.